Hello friends, in today's program we are going to uh, write delay using nested loop method. In this method basically we are going to write instructions of a particular delay, and we will be repeating those instructions again and again in order to get the larger delay. So I am going to write a random delay program for random delay generation. Okay, so this is MVI B comma F F H. I am taking a value 255. Hexadecimal value FFH is equivalent to 255 in decimal. So value FFH will be copied to register B, and after that I am going to decrease that value DCR B, and then I will check whether the content of B is 0 or not by using instruction JNZ. So JNZ and repeat, and repeat label will be here. I've already explained this program in my previous videos, so you can check the working and all the concepts there from my last video. So here now we will require t states of individual instructions to know the total time delay generated here. So for MVI B comma FFH, microprocessor takes 7 t states, that means 7 clocks. Okay, and for DCR B it takes 4 t states, and for GenZ repeat it takes 10 t state and 7 t state. Well, a GenZ instruction will check for carry 0 flag is equal to 0. Okay, GenZ will check for Z is equal to 0, and until it will get Z is equal to 0, this instruction will take 10 t state, and at last when content of B register will be 0, in that case this instruction will encounter Z is equal to 1, and for that case this instruction will take 70 states. So in order to get the total delay here, we will simply add all the time delays. So you can see here that 10t plus 4t, that means 14t will run 255 times. Well, equivalent decimal value of FFH is 255. So these two instructions will run 255 times, and after that this instruction will run only one time. So total delay will be 255 times 14 t states. This 14 come here from 10t plus 4t, and plus external, that is 7t. Okay, and in order to compensate this value, as at b is equal to 0, it will take only 7 t states. That means we will have to subtract 3 t states from overall delay value. Okay, so from here we will get and it will come 3 5 7 4 t states. Okay, so that means total delay we have generated by using these three instructions and putting a value FFH in register B is 3574 t states. Okay, here again I am telling you that if we have connected our microprocessor with a crystal frequency 2 megahertz, then in that case frequency generating inside the microprocessor will be half of this frequency, so that will be 2 by 2, that is 1 megahertz. Okay, and from there we can get the value of t. It will be 1 by f, and that is equal to 1 microsecond. So the value of t is 1 microsecond, and after putting the value of t here, we will get a delay of 3574 microsecond. Now what is nested loop method? In this method we will be repeating this delay again and again. That means, suppose if you are calling these three instructions 10 times, then obviously you will get delay greater than 10 times. So for the same I am going to repeat these three set of instructions 10 times. So in order to repeat those instructions, first of all I will have to take a register 10 in any register. So a value 10 in any register. So here equivalent of 10 is 0AH in hexadecimal. So I have taken 10 in register C, and after that write those instructions those you want to repeat here. So I want to repeat MVI B comma FFH DCR B J and Z repeat. Okay, and repeat will be here. So now I want to repeat these three instructions 10 times. That's why I will decrease the content of C and I will check whether it has become 0 or not. So for that I will write DCRC, and for checking I will write J and Z, and I want to send it back at a position named loop. So remember, when microprocessor will come out of this loop, at that stage the content of B will be 0. So if you want to again run this program, that means again you will have to put the value FFH in register B. That's why we will go back at this place. So I am going to write loop label here. Alright, so we have written our program. We are calling these three instructions 10 times, and we know that delay generated by these three instructions is 3574 microsecond. That means approximate, we are going to get a delay of approximate value 35740 microsecond, or you can say it as a 35.740 millisecond. Alright, so let us see. Again, this instruction will take 70 states, and for these instructions we have already calculated that these three instructions are taking 3574 T states. So I am going to write it here, 3574 T states. Then DCRC will take 40 states, and JNZ loop as before, when it will find the conditions true it will take 10 T states, and for false condition it will take 70 states. So now you can simply see that these three instructions, okay, that means 3574 T states plus 4 T state and plus 10 T states will run total 10 times. Okay, so that's why I'm going to write delay in loop. It will be first of all add all these values, that will be 3574 T. So 3574 T states plus 4 T states and plus 10 T states, and these T states will run 10 times. Okay, so I am multiplying here with 10, and after that there is also one instruction outside the loop, that is 70 states, and we will have to take care for that also. And again remember that when the content of C will be 0, on that case this instruction will take only 70 state, because this instruction will find Z is equal to 1. So in order to take care for that, we will subtract 3 T state from the overall value, and on calculation we will get this as 35884 T states, and on putting the value of T states, this will be equal to 35884 microsecond, or you can write it as 35.884 millisecond. So we have generated a larger delay, that is 35.884, that is the 10 times of delay using these three instructions. So in nested loop method, what is there? Simply you have to write a delay program here, and you have to repeat a number of times so that to get a larger delay. And instead of writing a delay program using 8-bit register, you can also write here program to generate delay using a register pair, and by that you will get larger delay value. Okay, so this is all for nested loop method. Thanks for watching.